Okay, well, good morning. Welcome all at this early morning hour of a last stage of a series of sessions on a relatively dark side of our field, toxicity and safety. Looking at the program today, I noted that fortunately almost every speaker not only highlight the problems, but also give a solution to those. And on this line, I happen to be the first speaker, so I introduce myself. I am János Szebeny from Budapest, Semmelweis University, and I'm going to talk about the risky side of pegylation of nanomedicines and biologicals, namely immunogenicity and immune reactivity. Let me just highlight what I'm going to talk about. I find it very useful to make a forecast so that you can follow where I am. Like a few words on PEG in general and pegylated drugs, then highlight the Pec Paradox, the immune side effects despite claims about the opposite, that PEG provides no or prevents immune side effects. And then talking about acute reactogenicity or hypersensitivity reactions or CARPA. This has been a subject over many years here, so I will try to go through it quickly, just for those who have not seen it. And then turn attention to the long-term immunogenicity, for which we have new data, previous evidence in murine models and our pig experiments over the past few months, and then the significance of all this. Well, PEG, as you all know, is a polyethylene glycol, oligo or polymer of ethylene oxide, also known as polyethylene oxide or PEO or polyethoxide ethylene. It is applied in the industry, cosmetics and medicine widely, and it is widely used among us for conjugating various drugs, for extending the circulation time, and these drugs include proteins and nanoparticles equally, or as nanomedicines. Now, we are all well aware of doxyl being a pegylated liposome, but little word has been devoted recently, or in general at this forum, on proteins, namely biologicals. For some reason it was called as being kicked out from this forum. Well, it's not kicked out because the pegylated forms of antibodies are legible nanoparticles. I mean, legal nanoparticles, legible and also legal. And there are a lot of examples for such pegylated proteins already in market. As you can see this list here. I will not read it, but you know that today this is the biggest market, the biggest business, and there's a lot more already in the market than showed here. Now here is the paradox, the Pec paradox, that we know PEG as somebody or something very beneficial for us in that by increasing the circulation time and decreasing the interaction with plasma proteins, it should reduce the interaction with the immune system. However, this is not quite the case because, as you will see, pegylated particles and proteins cause these two immune side effects, the subject of this talk. And even if you bring up PEG in the Wikipedia, you can read here that attachment of PEG to a drug or therapeutic protein can mask the agent from the host's immune system or reduce immunogenicity and antigenicity, which is apparent, it's clearly not quite true, so it is a paradox about PEG. And briefly, the CARPA concept, that is to say the immune reactions, the concept is that a large fraction of acute hypersensitivity reactions or allergic reactions to IV drugs is caused by complement activation or at least complement activation is an important factor in these reactions. And many state-of-art anti-cancer and other nanomedicines and therapeutic antibodies have heightened risk to activate complement and therefore cause these reactions. There are several groups of drugs which are known to cause CARPAs. You can see liposomal drugs, micellar drugs, and biologicals without PEG. This is our subject today. And radio contrast media, enzymes with and without PEG, and miscellaneous small other molecules. CARPA appears at the first treatment, no prior exposure. So CARPA is definitely different from immunogenicity in this regard. CARPA can be milder or absent upon re-exposure, and in this regard it is different from classic allergy, and it can spontaneously resolve. There's pulmonary infiltration in animal experiments showing this, and the high reaction rate is also unique to CARPA. And just to remind you, the symptoms, it can be mild, moderate, severe. You can read it here. These symptoms repeat many times in this presentation, so I don't read it here. The bottom line is that mostly they are mild or moderate. It does not require any intervention, but if it is severe, then the infusion or treatment has to be stopped. Now, looking at the evidence or public knowledge about these reactions, these lines were downloaded from the internet today. So even today, we can read about Doxil that infusion reactions can occur. Here are the symptoms, the well-known symptoms, and again, sometimes life-threatening and maybe fatal. And we can read the same about Neulasta. This is a pegylated protein, also known to cause reactions. We are going to talk about this today, so that's why I brought up the information. Reactions, serious allergic reactions, just the same symptoms here as we see everywhere. Running through the list of different drugs and proteins, I mentioned almost all liposomal drugs are on this list of reactions, and pegylated protein, in addition to Neulasta or pegfilgrastim, many others, this is only a small fraction of pegylated proteins which have been collected in this table. It was collected many years ago. Today, the list is at least 5 times longer. And reactions to marketed monoclonal antibodies, probably it is not exaggeration to say that almost all monoclonals show the reaction to smaller or less or more or less degree, but this is a general phenomenon. And what is important for CARPA is that we have a very good animal model, the pig model, which is briefly shown here. If we inject the animals with Doxil, a sudden drop of blood pressure, rise of pulmonary arterial pressure, and arrhythmias, many other symptoms, skin reaction we can see. So we say about the pig model that at the moment this is the most sensitive model of CARPA. But as you will see, this is not at all sensitive compared to what we see if we immunize the animal with a pegylated particle or protein, which I'm going to show you the next slides. But before that, let me just mention what is the evidence until to date about the immunogenicity of nanoparticles, of pegylated nanoparticles. The accelerated blood clearance of a second dose of pegylated liposomes was described first time in Healthstorm laboratory, who is here, and later on a Japanese group, Ishida and co-workers, have studied a dozen of publications about this phenomenon, showing that the injection in rats and mice of pegylated particles or pegylated proteins induces anti-PEG antibodies. And the phenomenon of ABC, the accelerated blood clearance, which is shown here, demonstrates that upon repetitive administration of the particle, pegylated liposome leads to accelerated clearance from the blood, so it makes the particle useless as a drug. And they actually show complement activation as the mechanism. They claim that complement is activated, then as a consequence, antibodies are formed in the spleen by B cells, and then these B cells, these antibodies bind to the particles which get then rapidly taken up because of the opsonization as a consequence of complement activation. And that is behind the ABC phenomenon. Another puzzling observation which attests to the presence of anti-PEG antibodies is the fact that there are many publications nowadays showing that at least 30 or 40% of us people have such antibodies in their blood. And the origin of these antibodies is absolutely not known. There are guesses, could be related to cosmetics or any other daily use items, but we do not know. But the experiments, which I'm going to show you in a few slides ahead, in pigs, you will see that the model will allow us to identify the mechanism of immunogenicity of pegylated proteins. And this is a reminder what we use in these experiments, doxibo, which is a doxorubicin-free doxyl equivalent liposome. And we immunize pigs with these liposomes. Here is the protocol. Pigs are immunized on day 0 with or without doxyl. And the reason why we apply doxyl is to see what happens if we also inhibit the immune system, at least with doxorubicin. And then we take samples at regular times at week 1, 2, 3, 4, and 6, and we use an ELISA, a homemade ELISA to detect anti-PEG antibodies. And here is the staggering observation, what we have got. After a week, there is tremendous immunogenicity, much more than in the rat of doxibo. This is IgM. And if we amplify the axis using a logarithmic scale, we can also see that initially, after the administration of the doxibo, the antibody level goes down. So this is considered as a natural antibody, and then it goes up at 1 week. So the conclusions from these experiments are these. Doxibo is highly immunogenic, leading to massive production of anti-PEG antibodies, which is primarily IgM. It peaks at day 8. The antibodies decline over 6 weeks. IgM and IgG responses have the same kinetics, which is important. IgM response is much stronger. Initial titer is not 0, implying natural antibodies, and there is an initial decrease at day 1 and day 2, which suggests that doxibo binds natural antibodies. And I have to tell, although not too long, that this kinetics of antibody formation is consistent with so-called T-cell independent immunogenicity, which is taking place in the spleen and the B cells, the so-called marginal zone B cells, and this is a so-called type 2 immunogenicity. Importantly, regarding the specificity of these antibodies, we find that when instead of doxibo, we immunize the animals with neulasta or PEG filgrastim, where there is no phospholipid, we get the same immunization, although the titer is somewhat lower, but at day 7, there is tremendous increase, which suggests that these antibodies are not directed against the phospholipid in the PEG-PE, which we use as antigen in the assay. This is just flashing the fact that antibodies are bound by injected doxibo on a time scale of minutes, which explains the phenomenon of CARPA. And when we inject doxibo or the protein at the time when the antibody level is high at its top, then the reaction, then CARPA becomes exaggerated, amplified. We get a huge reaction. It is not tachyphylactic as normally, and actually 3 out of 4 animal dies under such conditions, or at least died in our experiment under the symptoms of anaphylactic shock. And this is illustrated here. The blood pressure is falling in a matter of minutes to 0, and we have to salvage the animal with epinephrine in order to avoid death. And another interesting observation is that when we immunize the animal with Neulasta, then administration of Neulasta does not cause reaction, but administration of doxibo again triggers the huge reaction, which implies that the immunization with Neulasta produces IgM antibodies that cross-react with doxibo, causing amplified CARPA. But Neulasta itself does not cause reaction, which suggests that CARPA is more complicated than simply binding of antibodies to the particles. Probably depends on the inducer size, the liposome size. Liposomes are big enough to trigger the reactions, whereas the pegylated protein itself is not. It is immunogenic, but not immune reactive in these experiments. So to conclude, pigs provide a new functional model, and I emphasize his functional because there are no, to my best knowledge, there are no other immunogenicity models where the endpoint would be a functional change. And here the functional change is quite serious. It's an anaphylactic shock or anaphylaxis. And different pegylated nanoparticles induce anti-PEG antibodies that cross-react with the inducer PEG nanoparticles. However, triggering of CARPA have other preconditions as well, not only antibody binding. And pre-existing natural anti-PEG antibodies explain doxil-induced CARPA antibody. The lack of immunogenicity of doxil may be due to the cytotoxicity of B cells. I could not spend time on these experiments, but just to tell, when we apply doxil together with doxibo, there are no antibody formation, there are no reactions. And our data warn to a heightened risk of classical pathway complement activation mediated anaphylaxis upon repeated, and here I emphasize this, repeated pharmacotherapy with identical or different immunogenic nanomedicines. And thank you very much for your attention. That was it. And I don't know if I can give myself, okay, then maybe one. Yes, please. What is the question?
So is there a way clinically then to deal with this? Is it a rate of infusion that you deliver slowly, or do you do prophylaxis with, a combination of an antihistamine and a steroid, etc., to prevent this?
Not only there is a way, but these preventive measures are standard today, even with nanotherapy. All nanoparticles, even doxil, is nowadays administered under heavy pre-medication with steroids and antihistamines. So, yeah, clinicians are aware of it and want to avoid it. And still they show up occasionally.
So the effectiveness of pre-treatment is not 100% effective?
It is not. Yes, that's the problem. Yes, and these reaction rates, which are reported for the individual drugs, usually apply to patients who are pre-medicated. Without pre-medication, for example, the reaction rate for doxil was 45%. Well, then I would give the word, the podium to the second speaker, Moin Mogimi, who probably doesn't need to be introduced. He comes from all over the planet, this time from Durham.